Hello class. Now in this lecture we will see another term of thermodynamics, that is heat energy. Start from our school level we have studied heat is the energy, is the one kind of the energy. So there are various types of energy we have gone through, such as the sound energy, such as a light energy, okay, such as a kinetic energy, potential energy, chemical energy. So all those energy can be convertible into a heat energy, okay, and it is a very important, and heat energy is also plays a very important role in order to have a liveness of universe, okay. So to understand the importance of heat energy, we must know what is the third law of thermodynamics. Basically, there are only two laws we're supposed to study in our diploma courses. That is the first law of thermodynamics and the second law of thermodynamics. But third law of thermodynamics is not in your syllabus. But then also to understand the importance of heat energy, you must know what is the third law of thermodynamics. So in short, I try to explain it. As per the third law of thermodynamics, at the absolute zero temperature, okay, at the absolute zero temperature, the change in entropy of system is zero, okay. At the absolute zero temperature, the change in entropy of the system is zero. So here entropy is another term which we supposed to complete in our next lecture, okay. But just sake of time, understand uh, what is the meaning of third law, okay. So absolute zero temperature is nothing but the temperature of 0 Kelvin, or we can say temperature of minus 273.15 degrees Celsius. So it means that at that temperature, minus 273.15 degrees Celsius temperature, everything is freeze in such a manner, or it is such level, the electron of that particular substance also stop revolving inside their orbit around the nucleus, okay. Thing need to be noticed here, that temperature an electron also stop revolving around the nucleus, means we are thinking on nuclear that molecule level. At that temperature, electron also stop rotating around the nucleus at absolute zero temperature. So what it means, whenever heat energy is there, okay, so heat energy may be in the form of internal energy also there. Whenever anything is actually heat energy does not possess by any system, basically, okay, it is a transient phenomena, it won't hold by any system. But if temperature is there, okay, then there is a chance of flow of heat energy. So whenever temperature is there, then heat energy come into the picture whenever heat temperature is there. So at that absolute zero temperature, the electron stops their movement. So heat or energy, or we can say temperature, represents a liveness of object, okay. It represents a living being thing. Actually the plastic or any metal is not live thing, but then also inside that inside their molecule, the electrons are moving. So we can say it is kind of liveness, okay, for sake of time. So that much important is the heat energy, okay. In case of our automobile also, we are saying engine is not warm up till we are waiting. Even case of the dead body also, human dead body, the temperature falls below 35 degrees Celsius, we say it's a dead body. So warmness is important, okay. So heat energy is very important. And having temperature, if any system have a temperature, suppose T1 degrees Celsius, which is greater than absolute zero temperature, so it is doesn't mean that body having or that system have a heat energy. It is a region, or we can say it is a reason to have a heat energy in future, or it is that temperature is responsible to make a flow of heat energy, okay. But if particular system have a temperature greater than absolute zero temperature, then it doesn't mean that body possesses or that system possesses the heat energy, because no system possesses a heat energy, okay. We will see why I'm saying like that, okay, in the further lecture. But if you look for the heat energy as a definition wise, then it is an energy in transit due to a temperature difference between system and surrounding. Okay, so it is a heat, it is a transient form of energy. So what is the meaning of transient? Transient is nothing but, if we say in Marathi, a transient is nothing but shanik. It is for instant. So for instant, system have heat energy, but only when system and surrounding having temperature difference. For example, just take example over here. This is a system and this is a surrounding sake of time now. Okay, and the system have a temperature T1 and surrounding have a temperature T2. If this, just take in magnitude, for example, this is a 10 degrees Celsius and this is a 10.8 degrees Celsius. So there is a temperature difference, very small temperature difference, but there is a temperature difference. So heat energy start flowing from surrounding to system, as this is a 10.8 and as it is a 10. So this have a maximum temperature than system. So heat energy start flowing from surrounding to system. But as soon as the temperature of T1 also reaches to 10.8, heat energy flowing in between them will be stopped. So it won't, and once both body have or reaches to 10.8 degrees Celsius, then we can't say the system one, the system have a heat energy that much amount or surrounding have the heat energy in that much amount. No, in that time we will say it is having a internal energy, or we can say the system stored the heat energy in terms of internal energy, and the surroundings stored a heat energy in terms of internal energy. Now we can't say it is a heat energy. Okay, so till there is a temperature difference in between system and surrounding, for that time only we can say transfer of heat energy is there. Means it is just like that, something accidentally come into the picture whenever temperature difference is there. As soon as temperature difference is vanishes, both are acquire a same temperature, then it get we can say get height, and it changes their picture. For example, it changes its we can say swarup. It changes its swarup, means it converted into internal energy, and inside the system we can't say it is a heat energy. In that time we have to say it is a internal energy, not heat energy. Okay, as soon as both system and surrounding reaches to same temperature, so that's why it is a transient. It is appear for sake of time when a till temperature difference is there. As soon as both the temperature reaches to the same level, then it won't there. Okay, so that's why heat energy is a transient due to temperature difference between system and surrounding. It just governed by temperature difference. Okay, so that thing you have to remember. Okay, now another thing need to be understand over here, a sign convention of heat energy and the work. Heat and work both are a directional quantity. As in case of the mechanics, we have seen the positive force are those which are going upward side and which are going right hand side, while force resolution of resultant force. Okay, whenever we are resolving a force in mechanics, okay, that time the force which going in upward side and the force going at the right hand side are noted as a negative, and when those force are going at downward sign and going left hand side are noted as a negative. Same here also, a work and heat both are having a direction indication. Okay, directional indication, or that is sign convection. It doesn't mean that in case of the thermodynamics, if you have to only take a work input as a positive or work output as a positive. You have to select one sign convection. Means if you are considering work input as a positive, then you have to consider work output as a negative, or vice versa, but you have to hold at least one sign convection. Okay, and consequently your equation will be changes. So if you are taking input as a positive, then throughout the for equations you have to consider input as a positive. So your sign convention will be different. I mean to say, in some books are some book those sign convention is used as we supposed to see in for the lecture, but in some book it may be a different opposite of this. Okay, but it throughout the that entire textbook the sign convention will be fixed what they are assuming. Okay, so with respect to their sign convention throughout the equation it balance. Okay, so here what we have to supposed to consider in terms of heat. Okay, so if this is a system and this is a surrounding, whenever heat coming into the system from surrounding, whenever heat coming from surrounding to system, that time it will be considered as a positive amount. Okay, and it is happen only when a temperature difference in between them is there. For example, as we have seen previous example, if it is 10.8 degrees Celsius and it is a 10 degrees Celsius, there is a difference of 0.8 degrees Celsius in between them. So due to that, what happen, energy flowing from heat energy flowing from system surrounding to system. So it is a positive heat we are considering, as it is a heat gain, something is gaining by system. Okay, something is gaining by system, so it is a positive one. Now if temperature over here is 10.8 and surrounding at 10, so due to temperature difference heat start to flow out from the system, so that time heat lost by system, so it is a negative. Okay, it is a negative heat energy. Now come to the work. Whenever surrounding doing work on system, surrounding doing work from work on the system, that time we are considering negative work done is there. Whenever system doing work on the surrounding, that time we are considering it is a positive work done. Means our neighbor work for us. Okay, here surrounding, now consider surrounding as a neighbor, and the neighbor works for you, means you are taking a favor of your neighbor, that time it is a negative work. And whenever you work for your neighbor, means you are favoring to neighbor, that time that work be considered as a positive. Okay, so this is a sign convention what we are assuming over here. In some another book maybe exactly vice versa sign convention may be there. So thing is that you have to just hold a one assumption throughout the study of thermodynamics. Rest are everything. Whatever the value you are getting after the that sign convention will be same. Magnitude will matches and the only sign will be differ, but magnitude will be matches. So with respect to your sign convention assumption. Okay. So now just take an example how work will be positive and that uh, how work will be negative. Just take an example of our heat engine, our piston cylinder arrangement, most uh, our famous example. Okay, in case of the automobile piston cylinder arrangement. Okay, so consider piston. I am supposed to draw a piston cylinder arrangement over here, and those are the walls. Okay, so what is the system over here? I'm only considering system is nothing but a volume held by that region, not a cylinder my system, not a piston my system. Piston and cylinder body is just a boundary for me right now, but it is not a part of system. Remember, okay? Go just refer a definition of system and surrounding. Okay, so here system are only a volume present inside the boundary. So here those boundary is nothing but the wall of cylinder and the wall of piston, that top wall of piston, or we can say piston crown is nothing but the boundary. So whenever suction stroke are take place, that time is this supposed inlet valve is open, that time what happening, your air coming into the air of surrounding coming into the what, coming into system, that time work done by surrounding on system, it pushing the piston downward. Actually it's not pushing piston, going itself outward, downward. But who is doing this thing? A flywheel, a stored energy inside the flywheel will do this thing. Means outside the system, surrounding working on systems, surrounding working on system. So surrounding working on system, so it is a negative during the suction stroke, negative. Now let's take compression. After the suction, compression stroke will be there. So whenever this wall get closed and this wall get already closed, this is the inlet wall, this is the exhaust wall, so both wall are closed. Now piston moving upward direction, so compression will take place. Now piston are doing work on system is inside the boundary, only system. Now this boundary pushing upward, who push the boundary? Again stored energy inside the flywheel which push the boundary. Okay, or someone other person will store push the piston in upward direction. So system on system, a work done by surrounding, so again it is a what, negative work. Now expansion stroke is there. Now gas supposed to blast, or due to the chemical reaction of air and fuel, blast will occur and piston pushing downward direction. So that time whatever the system air and fuel present inside the boundary will push the piston downward, means boundary is supposed to move downward direction, is supposed to expand. Now system doing work on surrounding, so it is a positive. Now exhaust stroke will be there. As soon as exhaust valve get open, that time piston move upward in order to swept up all the gases present over here through system to surrounding. So that time who will push the piston upward? Again stored energy inside the flywheel push the piston in upward direction, and flywheel is not a part of system, it is definitely surrounding. So that time surrounding doing the work on the system during the exhaust stroke. So again surrounding doing the work on the system, so it is a negative work. Okay, so this is a sign convection. Simple word, if you say when surrounding doing a work on system, then it is negative. When system doing work on the surrounding, then it is positive. In terms of heat, when heat flowing inside the system from surrounding, then it is a positive. When heat flowing from system to surrounding, then it is negative. Okay, a very simple, need to be remember for the further numericals. Now what are the similarity between heat and work? Let's check out those things. Both heat and work are directional quantities, so require both a direction and magnitude, as we have seen here. As it flowing in or it flowing out, on that basis we are giving it is a positive and negative. Or you can say heat and work are both are opposite for remembering purpose. Okay, it is simple. Here it is positive, so here it is negative. Here it is negative, so here it is a positive. So both are having a direction as well as magnitude. Okay, so whenever I'm saying work done by surrounding on system, that is 10 kilojoule. So when I'm representing it, so I'm taking it is a minus 10 kilojoule. So with sign also I have to represent now. But work done is never minus. That negative sign indicates it is a work by surrounding to system. So to describe it, work done is there, 10 kilojoule of work done is there, but whom does a work on? Okay, who does the work on whom, that we have to specify by that sign. So whenever I'm saying minus 10 kilojoule of work done is there, then it is defined as a 10 kilojoule of work done by surrounding on system. So it is very simple to understand. So that's why it requires direction as well as magnitude. Now both are path function and inexact differential, as we have seen in case of the point function and the path function lecture. The temperature, volume, pressure, enthalpy are the point function which is only depend on the end state, initial and the final state. In between initial and final state, there are n number of paths, okay, through which we can perform a process. So those things, work and heat, in the previous lecture also we have seen work is depend on the path, that is shaded area lecture. the shaded area under the curve, it's varying. So with respect to the path, it varying. So work done also vary. So in that case, similarly in case of the heat also, it vary with respect to the path, and it vary with respect to the process also, because each path represent different process. Okay, some process may be isothermal. Okay, some process may be isentropic, some process may be isobaric or isochoric. So all those process differ with respect to that curve. Okay, so the nature of curve will be different with respect to the process. So if path different, value of heat and work also different, means process also different. Okay, because each line representing a different process. So still we have not completed types of process. In the further lecture we supposed to see those things. Okay, processes. So just for sake of time, just remember that each line in between initial and final path representing each process, and different processes, or means it not like that same characteristic they have. Line are different, curves are different in between initial and final path. It means they having different characteristic and different law of process. After that, both are transient in form of boundary phenomena. Both are transient in form and boundary phenomena. Transient means was it is a shanic, as we have seen. And what is a boundary phenomena? It crosses the boundary, it won't hold. For example, in bucket, if 10 degrees Celsius of water is there, then we can't describe that system as that bucket have 10 degrees Celsius of heat energy. Not like that. We only describe like that particular system have a system at 10 degrees Celsius. Okay, in that fashion we supposed to describe, because as I told you, heat energy will not be possessed by system. It always flow across the boundary. Okay, it won't hold by system, or it won't hold by surrounding also. If temperature between system and surrounding are same, then heat energy will not be appear. It only appear when temperature difference is there. Until temperature difference is not there, that heat energy changes its picture and it gets stored in the form of internal energy. As soon as temperature difference appear, heat energy get active. It changes its picture from internal energy to the heat energy in order to make the temperature difference zero. Okay, so that's why it not possessed by any system. It is a transient in the form, and it is boundary phenomenon means it only exit across the boundary. It transferring continuous heat and work both. Okay, it's not like that a particular bucket of water holds a 10 kilojoule of work. We can't describe like that, that bucket of water of 10 degrees Celsius hold a 10 kilojoule of work. So it is not describable characteristic. Okay, so that's why it is a boundary phenomena. We can't use heat energy and work to describe anything, to describe a system. Okay, now heat and work both are having a same unit, that is joule. So we all know that is famous experiment done by Joule, in which he is supposed to allow a weight of mass m, same mass weight, from initial point to the final point. Okay, due to the gravity, in order to stirrer inside a beaker of insulated beaker. So just remember that experiment. I want to recall that, just in order to say a heat can be developed, a same amount of heat can be developed by same amount of work done at any instant. Okay, so same amount of work can develop a same amount of heat, but we can mean to say a work can be 100% converted into heat, that they are defined by the Joule. Okay, and it also explained by the Joule, because he did a same experiment with various or n number of for n number of time, or it takes a number of iterations with the same amount of work. He's supposed to heat a water present inside the beaker, insulated beaker, and every time by giving a same magnitude of work, water temperature reaches to that particular level only. So work can be converted into heat 100%. Okay, means 100% work can be converted into heat, but heat cannot be converted into 100% of work. It's some amount of it may stored as internal energy, and only some amount of work can be we are getting as output. Okay, but work can be 100% converted into heat energy. And this thing, on the basis of that experiment, he developed one correlation between heat and work. Okay, he derived a multiplication factor, or we can say coefficient, which uh, comparing heat and work together. Okay, and previously we was using a unit for heat, that is calorie, but they by using a joules factor. Okay, the unit of the heat and work come on the, bring at the same platform, so that's why heat and work can be termed as joule also. Okay, so these are the those are the similarity of heat and work. And till here we have studied a different thermodynamic terms. The most important term, that is heat, work and heat energy. So I feel you have understood the heat and work. So if still if you feel any difficulty, do comment in our comment section. Thank you.